Hello, sixth graders. Welcome to sixth grade math areas of composite figures lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is, I can find the areas of composite figures by completing practice problems with 100% accuracy in multiple attempts. The standard we'll be working on today is find the area of regular and irregular polygons by composing into rectangles or decomposing into triangles or other shapes. Please be sure this vocabulary is in your math notebook. A composite figure is made up of triangles and squares, rectangles, and other two-dimensional figures. Here are two examples, and you'll see they have something that kind of looks like a house with a rectangle on the bottom and a triangle on the top. And then they have a trapezoid with a square on the top. So those are two examples of composite figures. To find the area of a composite figure, separate it into figures with areas you know how to find. Then find the sum of the areas of those two figures. So remember that sum means you're adding. Let's take a look at example 1, finding the area of a composite figure. Find the area of the purple figure. So that's what the question is asking us to do. And our directions say you can separate the figure into a rectangle and a trapezoid. Count the grid lines to find the dimensions of each figure, then find the area of each figure. And off to the side, we have this pretty important note. It says, there is often more than one way to separate composite figures. In example 1, you can separate the figure into one rectangle and two triangles. So I'm going to do this on the right-hand one. You could do a long rectangle in the middle and two small rectangles off to the side. And you might want to remember that trapezoids can always be separated into a rectangle and two small triangles. So if you have a hard time remembering that area of a trapezoid formula, you can just separate it into a rectangle and two small triangles and you'll be fine. So we're going to start with step 1, and we're going to do this the way the book separated it, but know that if you aren't comfortable with this, you could do it a different way. So we're going to find the area of our rectangle. So we write our formula, which is length times width equals area, and we substitute in our values 6 units by 4 units, and then we multiply. So we have our area of a rectangle equals 24, and that's just 24 units. We don't know how big this is, if it's yards or feet or miles or whatever. And then step 2 is we're going to find the area of the trapezoid at the bottom here. And so we write our formula, area equals 1/2 height times base 1 plus base 2, and then we substitute in our numbers. So our base 1 is 4, so that's the top of the trapezoid. Our base 2 is 8, that's the bottom. Our height is 2 units, and then 1/2 of all of that. And when we simplify that, we have 12 square units. So in order to find the area of the whole thing, we have to add our 24 and our 12. So our answer is 36 square units. So there's a third step in here, which is add. Let's take a look at example 2, which is our real life application. And it says, find the area of the fairway between two streams on a golf course. There are several ways to separate the fairway into figures whose areas you can find using formulas. It appears that one way to separate it is you can use a right triangle and a rectangle. Identify each shape and find any missing dimensions. So they make it kind of easy for us because they've redrawn this as the rectangle and the triangle. So that's kind of a tip for you if you're given a problem where you've got something that has kind of a picture on it, and like this one has different lines on it that kind of make you see things differently, you can redraw that shape with just the outside lines, and that's sometimes helpful. So let's look at what we've got. We've got the area of a rectangle, and so our step one is finding the area of our rectangle, and we multiply the length times the width. We substitute in those values 70 and 40, which gives us 2,800 square yards. And then we have the area of the right triangle. And remember, your area of a triangle formula is 1/2 base times height. So the base of this is 40 and the height is 30. So the base is down here. That's the part that it's sitting on. And we multiply that and we get 600 square yards. So that was step 2. And then step 3 is to add them. So this in here is step 3, is add. And when we add them, we come up with 3,400 square yards for an answer. Remember, to complete your lesson, you need to be sure your notes in your ISN are complete. Do your Google form questions, review your lesson if you need to, and complete your Big Ideas math assignment in your math notebook. Be sure you submit that assignment when it is 100% correct and not before. Track your progress on your playlist.